And today's lesson is the application of the electrical waveform. So electrical waveform will be the sinusoidal wave, sawtooth wave. So the square waves, so those waveforms we can make the integration. Okay, firstly we will find the average value. Okay, we find the average value. So this is the waveform. The vertical axis will be the IT, the horizontal axis will be the T. So this waveform, see, this is a sawtooth waveform. So the time is start from 0 to 0.1. So this is for the T. Duration T. So this is the IM. The maximum value. So we can write the equation for the sawtooth waveform. This sawtooth wave equation is, you can write the equation. That this will be the ID is equal to IM by T multiplied with T. So this is the equation for the sawtooth waveform. This waveform function is like this. So this equation, you can write this one. This is the IM. Here, this one is the IM here. So this becomes the T. So this is function will be the ID. Okay, this horizontal will be the time is the T. So this is slope. The straight line slope, you can write the equation ID is equal to IM divided by T multiplied with T. Okay, we can find the average value. The equation to find the average value is I average is equal to 1 by T integration 0 to T ID dt. So this is the equation to find the average value. So this equation to find the average value is 1 by T integration 0 to T ID dt. So now we can substitute. So the ID is equal to the IM T divided by T. So this is we can find the I average. So 1 by T integration 0 to T. So instead of the ID you can substitute IM T by T into dt. So in this case, only there's a TDD is a variable. The other thing you can take out. So that you can take out here. So this will become that. So that this one you can take out. So this becomes as a IM T square integration of 0 to T dt. So this one you integrate. So this one integrate, what you got is a IM by T square. So this is T square by. So substitute from T to 0. So that now you can substitute. So upper limit is a T, lower limit becomes a 0. So that the function T integrate, you got the T square. So upper limit is T, lower limit is 0. So you substitute the upper and lower limit. So IM by T square. And this is divided by 2. So this one equation. So this one is that so this is 2D square here. So upper limit square, so you T square minus 0. So this is the IM by 2D square into T square. So you got the IM by 2. So this means that when you integrate the square sawtooth wave, the average value is the maximum value divided by 2. So this is the average value. And also you can also make the integration of the sine wave. So sinusoidal wave. So the waveform will be like this. Sinusoidal wave. So this will be the half sine wave. So this is a start 0 to pi here. And this is 2 pi. So this period will be the omega t. The period is omega t. So this will be the I omega t. So this because the maximum value is IM. So this horizontal axis will be the T and omega t. So this is a waveform here. So this waveform, you also have to find the average value. So in this case, because of that this is a half sinusoidal wave, I omega t function. average value. And also you can also make the integration of the sine wave. So sinusoidal wave. So the waveform will be like this. Sinusoidal wave. So this will be the half sine wave. So this is a 0 to pi here, and this is 2 pi. So this period will be the omega t. The period is omega t. So this will be the I omega t. So this because the maximum value is Im. So this horizontal AC will be the t and omega t. So this is a waveform here. So this waveform, you also have to find the average value. So in this case, because of that this is a half sinusoidal wave, I omega t function can be written Im sine omega t. So this is between pi to 0. So this is the omega t is between pi and 0. So omega t is between pi and 0. The function is I omega t is equal to Im sine omega t. So we have to find the I average. So we also have to use the equation so that the same formula we get, right? I average is equal to 1 by t integration 0 to t I dt. In this case, this function is I omega t, so that you have to substitute the I omega t dt. So the I average is equal to, so why you use the omega? Because the frequency. The waveform is composed of the frequency, so that to include the frequency, you have to use the omega t. The omega t means that this is enough. We also utilize the frequency. So that the equation is for the average value, that equation is 1 by t integration 0 to t I omega t dt. So this becomes 1 by t integration 0 to t. This is only t, but in this case omega. Because the frequency, you have to put the frequency. I omega t dt. So we call that this equation. Alright, then we have to substitute. So I omega t is Im sine omega t. So this one is substitute here. T is equal to pi. So T is similar to pi. And also you can substitute I omega t. I omega t is equal to Im sine omega t. So this one you can substitute. So we got the thing is that Im average is equal to 1 by t is 1 by pi. And the integration 0 to, so in this case t is equal to pi. So 0 to pi, I omega t you substitute In sine omega t and the dt. So we go like this. So now we want to integrate. So we want to integrate means this two must be the equal. If this one should, this is the omega t. The after this should also be the omega t. So that you can make the integration. Otherwise you cannot integrate. So that we have to put the omega here. So that we can substitute. So this is the I average is equal to 1 by pi. So you put the omega. So this is omega here. 0 to pi. Im sine omega t d omega t. Like this. So this is, then you can make the integration. Okay, then you can integrate. So integrate the sine, you want the minus cos. So this becomes a minus cos. So this is the I 1 by pi into omega. Because this t is equal to the omega t. So pi is equal to omega t. So the period will be the t is equal to pi into omega. So this is t is equal to pi by omega. So t is equal to pi by omega. So this is the t is equal to pi by omega. So this is the t, you can substitute it. This is a pi by omega. So pi by omega means this is a pi by omega. Sine omega t into dt. Okay, so this one, this omega you put to here. So this becomes a 1 by pi, 0 to pi Im psi omega d d omega d. So P is equal to the omega d is equal to pi. So this period, so the P is equal to pi by omega. 1 period is equal to the pi divided by omega. So we substitute that instead of t, you substitute the pi by omega. So this becomes the omega here. This is the denominator becomes the pi. So this omega we multiply to this side. So this becomes the Im by omega d d omega d. So this becomes the Im by pi. So integration of 0 to pi psi omega d d omega d. So you integrate, that will be the minus cos. So this becomes the Im by pi minus cos omega d 0 to pi. Okay, then instead of omega d you substitute pi, you also substitute the 0. So this becomes the Im by pi minus, so this minus is here, cos pi minus cos 0. So this is a become the Im by pi. And the minus cos pi is a minus 1. Cos 0 is also minus 1. So this becomes a this becomes a 2 pi 2 Im by pi. So this becomes a 0.636 Im. So the I average is equal to 0.636 Im. That's for the sinusoidal wave. Okay, this problem is that this is just all period is composed of the frequency. So this is a 0 to pi is a similar equal to the pi omega t. So the t is equal to pi by omega. Omega t is equal to the 0 to pi. Because the prevent this one, there are so many frequencies. Because of this one, you get calculated period. So period you get calculated pi by omega. So we use this equation. I average is equal to 1 by d integration 0 to d I omega d dt. Because this one we compose of the frequency. Frequency that should be the omega t. So the t you substitute, t is a pi by omega. Okay, so I omega d equation is the Im sin omega d dt. So that this one is omega go to numerator here. So this omega multiplies with this one. So that will be the Im sin omega d d omega d. So then you have to integrate. By integration, and then you substitute that upper limit and lower limit. Finally, you got the every value is maximum magnitude multiplied with 0.636. And today's lesson is the application of the electrical wave. Calculate the RMS value. So this is for the every value. So we use the integration to calculate the every value. So that for the triangular waveform, the every value is maximum voltage value divided by 2. For the sinusoidal waveform, the every value will be the 0.636 multiplied with maximum value. So this is for the every value calculation. Another one is we use the root mean square value, RMS value. So that we use that formula to calculate IMS. So IMS is equal to square root of 1 by t integration 0 to t it square into dt. So this is a formula to calculate the IMS value. So root mean square value. The equation is square root of 1 by t. So integration 0 to t it square dt. So this is the equation to calculate the IMS value. Now we want to calculate the IMS value for the triangular waveform and the sinusoidal waveform. So the triangular waveform we have to calculate. Triangular waveform, the equation we can substitute the triangular waveform equation. So the triangular waveform equation is it is equal to Im t divided by t. So this is the equation for the triangular waveform. So that we have to substitute the triangular waveform. So that for the triangular waveform, it is equal to Im t multiplied with t. So here instead of it you have to substitute the Im t divided by t. So this becomes the IRMS is equal to square root of 1 by t. So integration 0 to t. So we have to substitute Im t by t square into dt. So this is for that. Then you have to substitute here. So far we got is a integration 1 by t square and 1 by t. So 0 to t Im square t square by capital T square into dt. Okay, we got this one. Then we have to substitute. So this we began as a Im square. So this is a Im square is a constant. T square is also constant. So you have to take out the constant. So then will be the 1 by t multiply Im square by t square. So this becomes the integration 0 to t square dt. So we got. Okay, then you have to integrate the t square dt. So t square dt, so this becomes the square root of Im square by the t cube. So you integrate, so this is the t power 3 by 3, and lower limit is 0, upper limit will be the t. So we have to substitute the upper limit and the lower limit. So that becomes the square root of Im square by t cube. So upper limit you substitute t power 3, lower limit is 0 by 3. So this becomes the square root of Im square by t cube, upper limit t power 3, lower limit 3. So this is the t cubes are cancelled. So this becomes the square root of Im square by 3. We call like this. Okay, then you have to integrate. So this is the, you find as a square root. So this becomes the Im square root we got. So this becomes the Im divided by root 3. So this is becomes the IRMS. So IRMS for the maximum, IRMS value for the triangular waveform is the maximum magnitude divided by root 3. So by this way you can calculate. Another one is that we can calculate the IRMS value for the sinusoidal wave. So sinusoidal waveform, we also have to calculate the IRMS value. So sinusoidal waveform is equation if we already know the thing. So Im sinusoidal is a I maxima sin omega t. So this is for the sinusoidal waveform. So we have to substitute as I maxima. So this is the sinusoidal waveform. Id is equal to I maxima sin omega t. So this is for the sinusoidal waveform. Also, we also get the frequency. So because of this one, the t is equal to the pi by omega. So t is equal to pi by omega. So both things we have to substitute. So we substitute the equation. So the IRMS is equal to square root of 1 by t and 0 to t. Okay, so this becomes as you have to substitute. So id square. Id becomes the I maxima sin omega t square and the dt. So then you have to substitute. Okay, in this case we have to substitute here. So in this case, square root of t is at pi by omega. So this becomes a substitute 1 by pi by omega. So this is you substitute integrate from the 0 to pi. So this becomes a Im square sin square omega t into dt. We go. So this becomes a square root of, so 1 by omega by pi. Omega by integration 0 to pi Im square sin square omega t in the dt. So this omega we substitute to here. So this becomes the square root of 1 by pi integration 0 to pi Im square sine square omega t and a d omega t. So we go like this. Okay, this Im square you take out because this one is a constant. So this becomes Im square by pi integration 0 to pi sine square omega t and a d omega t. This equation. So you cannot directly integrate the sum. You have to use the trigo formula. The trigo formula is sine square cos 2 omega t is equal to 1 minus 2 sine square omega t. And by this way you can calculate sine square omega t. So sine square omega t is equal to 1 minus cos 2 omega t divided by 2. So this is the equation. To calculate the substitute the sine square omega t. So in the place of sine square omega t, you can now substitute the 1 minus cos 2 omega t by 2. So this becomes the integration Im square by pi and 0 to pi 1 minus cos 2 omega t by 2. So this one and a d omega t. So this one we have to substitute. Okay, we substitute here and then we have to make the integration. So this 2 is the constant, so take out the 2. So this becomes the integration Im square by pi. So this is 2 is set, take out here. So integration 0 to pi 1 minus cos 2 omega t d omega t. So this is the integration Im square by 2 pi. So integration 0 to pi d omega t minus integration 0 to pi cos 2 omega t d omega t. Okay, so this one integrate. So this integrate and differentiate, that's why we can say. So this becomes Im square by 2 pi. So this is omega t. Minus, this is a cos differentiate. So cos differentiate, you got the sine. So this 2 omega, so this becomes 1 by half sine omega t. So this is a substitute from 0 to pi. Then you have to substitute the pi and the 0. So this becomes a square root of Im square by 2 pi. So you substitute the pi minus half sine pi. And minus substitute 0 minus half sine 0. So sine 0, 0, so the whole thing becomes a 0. Okay, pi is equal to the 0. So only the pi left, because sine pi also 0. So only this you can let is square root of Im square divided by 2 pi into pi. So pi and pi cancel. So this is the Im by square root of 2. So Im by square root of 2 is 0.707 Im. So this one we got. So this means the IMS value for the sinusoidal waveform is the square root of the maximum value divided by root 2, then you got the IMS value. So in this sinusoidal waveform, we usually calculate the IMS value. So maximum value divided by root 2, you got the IMS value. So this is the derivation. How we got this root 2. Calculate the IMS value. So this is for the every value. So we use the integration to calculate the every value. So that for the triangular waveform, the every value is maximum. Okay, the next topic is IMS value of the complex waveform. So electrical waveforms are composed of the harmonic. Harmonic means for example, fundamental frequency is 50 Hz. The first harmonic second harmonic will be 2 times the first harmonic is the 2 times the fundamental frequency. This will be the 100 Hz. Second harmonic will be the 150 Hz like this. So this is the 2 times, 3 times the fundamental frequency. So 2 times fundamental frequency, this is second harmonic. 3 times fundamental frequency, that will be the third harmonic. Those harmonic waveforms are included in the AC waveform. So that we can write the equation. So period is the T square to 2 pi by omega. So this is the one period. So the waveform you can calculate I square to I0 plus A1 cos omega t plus A2 cos 2 omega t plus A3 cos 3 omega t, and also the combination plus B1 chi omega t plus B2 sin 2 omega t plus B3 sin 3 omega t, and so on. So this is for the IMS value. So this is the waveform, the electrical waveform, which composed of the all harmonic can be written in this equation. I0 is the DC value, this is the constant value, and this one is the A1 cos omega t and the B1 sin omega t are fundamental. After the second harmonic, A2 cos 2 omega t, A3 cos 3 omega t, and also the B2 sin 2 omega t, B3 sin 3 omega t are included. So those are harmonic terms. So waveform can be the cos wave and sine wave combination. So this is a generalized waveform. Some waveforms are sine wave, some are the cos wave. So they are combination waveform. So this is the equation for the harmonic. So in this case, you can calculate the harmonic IMS value. IMS value is you can calculate this formula. IRMS is equal to square root of I0 square plus half into A1 square plus A2 square plus A3 square, so on, plus half into B1 square plus B2 square plus B3 square, so on. So this is that we can calculate the harmonic. So by this way you can calculate the equation. Also then you also write the equation, the square root of I0 is the DC current, IDC square, the A1 square by 2. So this is the A1 IMS square plus A2 IMS square, so on, plus B1 IMS square plus B2 IMS square, so on. So this is for the we can calculate the harmonic by this way. So that the equation will be the sine of the half IMS square of the wave component, waveform. So this is the equation to calculate. So this is for the DC plus sine of IMS square. So this is for equation to calculate to the harmonic, to the IMS value. So by based on this principle, we will solve the one problem. So this current is given. The ID is given. ID is equal to 10 plus 15 psi 100t plus 5 psi 200t ampere. You have to find the IMS value. Okay, this equation we just write the equation here. IMS is equal to, the equation is square root of DC square, 10 square plus half into 15 square plus 5 square. So by solving this one, you got the student current will be there 50 ampere. So this is for the for my solution. Another one is that we can calculate the form factor. So the equation to form factor factor is equal to the IMF value divided by every value. So this is for the form factor. So form factor you can calculate. Form factor is equal to IMF value divided by every value. So the IMS value is a decimal you can substitute IMS and every value I every. So this is from the form factor. So the form factors are different depending on the kind of the weight sheet. So rectified square weight form factor is 1, side weight form factor is 1.11, triangular weight form factor is 1.15. So this is the weight sheet. And this is the form factor. The four letters are square weight, so rectify square weight. Square weight. So in this case, form factor 1. And side weight, so rectify side weight. The form factor will be the 1.11 and triangular weight. The form factor will be the 1.15. So this is the waveform, that and the form factor. Okay, so firstly we have to find the average value. So average value you can use two formulas to calculate. One formula is the average. If you use the time, you can use this formula. 1 by t, 0 to t, so integration 0 to t and vt dt. This is for that we can use the time. Or if you use the angle, you can also use this formula. The average is equal to 1 by 2 pi integration 0 to 2 pi v angle theta and d theta. In this case, theta is equal to omega t. So this is two formula. So you can use this every value by the two formula. If you want to use the time, the average you can calculate 1 by d integration 0 to t v d dt. And if you use as an angle theta, in this case you can also use as another formula. The average is equal to 1 by 2 pi integration from 0 to 2 pi and v theta d theta. In this case, theta is equal to the omega t. Omega t is a radial frequency. Omega is equal to radial frequency. This is equal to 2 by f. So 2 by f means 2 by multiply frequency. So this we call the radial frequency. Okay, then first I will calculate by using the two methods. Okay, method 1 we use the average value. So integration 1 by t integration 0 to t. So vd dt. So instead of the vd, you can now substitute the equation. The equation is tan minus tan sine omega t. So this is a substitute in the place of the vd. So then we got the 1 by t integration 0 to t. So then we got the tan minus tan sine omega t and the dd. So we go like this. Okay, then you calculate. So this is in this case when you integrate. So this becomes that you integrate 1 by t. So this becomes the integration 0 to t tan. So tan dt minus the integration 0 to t tan sine omega t dt. So this rule. So that you integrate the tan dt, so only the t coming out, tan here. So this becomes the 1 by t. So tan t. So 0 to t. Substitute minus. So this is the omega t. This is only t. So you have to divide by omega. So tan sine omega t t omega t divided by omega. Otherwise you cannot integrate. This is a sine omega t. after d dash should also be the d omega d. So to got the omega, put the omega here at the numerator, and the denominator you divide by the omega. And then you have to now substitute. You can now substitute the 1 by d, so this is 10d minus 10 by omega integration 0 to d sine omega d d omega d. So sine integrate, you got the positive cos. So this one in this case that you can substitute 1 by d 10d minus 10 by omega. So this becomes the sine integrate, you got the integrate the sine, you got the minus cos. So minus cos means that this minus and this minus multiply, this is plus. So this is omega d. So 0 to d. So then you now substitute. So d substitute and 0 substitute. So this is a 1 by d 10d plus 10 by omega. Okay, you substitute d, that becomes a cos omega d. Minus, you substitute 0, this is a cos 0. So we go like this. Okay, in this case, omega d is equal to 2 pi. So in this case, we can write the equation omega d is equal to 2 pi. This is a general relationship. Omega d is equal to 2 pi. So that instead of omega d, you can substitute the 2 pi. So this is a 1 by d 10d plus 10 by omega cos 2 pi. Minus cos 0 is 1. So 2 pi is also the so cos 2 pi you now substitute. So cos 2 pi is that 1, so that will be cancelled. So that we can 1 by d into 10d plus 10 by omega cos 2 by 1 and cos 0 is 1. So then will be the whole thing will become 0. So this becomes 10 volt. So this is that we substitute that we use the formula 1 by d integration 0 to d v dt. So this is the first method. And second method you can also calculate. Second method is you have to use the formula. V average is equal to 1 by 2 pi into 0 to 2 by v theta d theta. So that equation we also substitute. So the V average is equal to 1 by 2 pi. So integration 0 to 2 pi. And V angle theta and the d theta. In this case, theta is equal to omega d. Okay, now we substitute the equation. The V d is equal to 10 minus 10 sine omega d. Instead sine omega d, you substitute the theta. So this is the 1 by 2 pi. Integration 0 to pi. 0 to 2 pi. So V angle theta. So V angle theta is equal to 10 minus 10 sine omega d. Instead of omega d, you have to substitute the theta. So this is 10 minus 10 sine theta and d theta. So the equation. So now we integrate. So this is 1 by 2 pi here. So that 10. So this becomes the integration 0 to 2 pi 10 d theta minus integration 0 to 2 pi 10 sine theta d theta. We got. Okay, so upper limit you integrate this one. So 2 pi. So this is a 10 angle theta 0 to pi. So this is a sine integration, you go to positive. So this is 10 cos theta. Lower limit 0, upper limit is 2 pi. Okay, then now you substitute now. So this becomes 1 by 2 pi. So this is a 10 pi plus 10 cos 2 pi minus cos 0. So cos 2 pi is a cos 360 degree. So cos 360 degree you calculate. This is a 1. Cos 0 is equal to 1. So the whole thing will be cancelled. So only 10 by left. This is the put a 2 pi here. 2 pi, so this becomes 20 pi. So 20 pi divided by 2 pi, you got a 10 volt. So this is for the we can make integration. So you got the same magnitude. This is for the every value. Every value we calculate. Another one is that we have to also calculate the RMS value. So VRMS. So VRMS also we can use two equations. One equation is square root of 1 by t integration 0 to t vt square dt. Or another equation VRMS is equal to square root of 1 by 2 pi integration 0 to 2 pi v angle theta square t theta. So this is two equations we can utilize. So first equation you use the time, second equation you use the angle. So to find the RMS value you can use the two magnitude, square root of 1 by t integration 0 to t vt square VRMS equal square root of 1 by 2 pi integration 0 to 2 pi second one will be the easier. So we have to utilize the second one. So I will use the second one. So in this case, sin omega t, you have to substitute the angle theta. So this equation, original equation 10 minus 10 sin omega t, it is equal to 10 minus 10 sin angle theta. So this is the we now substitute here. So square root of 1 by 2 pi integration root 2 pi. P theta is 10 minus 10 sin theta square d theta. So we go like this. Okay then, so this is 10 is substitute. So 10 substitute here. So this is 1 by 2 pi. So integration 0 to 2 pi. So this is a 10 1 minus sin theta square d theta. So this becomes a 10 square. So 10 square is 100. So 100 divided by 2 pi, you got the 50. So you got the 50 here. So square root of, so this becomes a 50 by 5. So 0 to 2 pi. 1 minus sin theta square d theta. So 1 minus sin theta square d theta we got. So this one we separate. So square root of 50 by 5. Okay, so 1 minus sin theta square is a 1 minus 2 sin theta plus sin square theta. So this is become a integration 0 to 2 pi. 1 minus 2 sin theta plus sin square theta into d theta. Because of that, this is a function. If you use as a 1 minus 8, the whole square is equal to 1 minus 2a plus a square. So similarly, this is the power function. So 1 minus 8, the whole square is equal to 1 minus 2a plus a square. Similarly, 1 minus sin theta, the whole square is equal to 1 minus 2 sin theta plus sin square theta. So then now we integrate. So integration 50 by pi, so 0 to 2 pi. And d theta minus integration 0 to 2 pi 2 sin theta d theta plus integration 0 to 2 pi sin square theta d theta we got. Okay, now we substitute here. So square root of 50 by pi. So this is the d theta you substitute. This is 2 pi. Okay, 2 sin theta d theta. Sin integration you got the positive. So positive 2 cos theta. So 0 to 2 pi. And sin square theta. So we cannot directly integrate the sin square theta. You have to substitute. So sin square theta is equal to the 1 minus cos 2 theta by 2. So this is the sin square theta is equal to integration of 0 to 2 pi 1 minus cos 2 theta by 2 into d theta. So those things we got it. Okay, then we solve this one here. So this is as a square root of 50 by pi. So this is 2 pi plus 2 cos 2 pi minus cos 0. So this is integrate. So the half d theta. So 0 to 2 pi. Minus integration 0 to 2 pi cos 2 theta by 2 into d theta. So we got like this. Okay, so this is you substitute the cos 2 pi, 360, cos 0 is 1. So this one will be cancelled. So this one will be the 0 here. Because of the cos 2 pi is cos 360, cos 0, 360 is 1, cos 0 is 1, so will be cancelled. So this one we substitute. So that will be the square root of 50 pi into 2 pi. So this one substitute is a 2 pi by 2 minus, so integrate. So this one is you cannot integrate here. This is 2 theta. So here you should put the 2 theta here. 2 theta, so numerator you have to divide by 2. So this becomes really this one is becomes as a cos 2 theta d 2 theta by 4 like this. So then you integrate the cos. So you got the side. So this is the minus side. So minus sine 2 theta by 4. So substitute 0 to 2 pi. So this becomes the square root of 50 by pi. So this one is the 2 pi by 2. So this becomes a 3 pi. 3 pi minus sine 4 pi by 4. So sine 0 is at 0. So sine 4 pi is sine 720 degrees. So sine 720 degrees you also substitute. So this becomes also as a 0. So sine 4 pi is sine 720 degrees. So pi is at 180 degrees. So sine 720, you use the calculator, you got a 0. So the whole thing will also become a 0. So only 3 pi is left. So 50 by 5 multiplied with 3 pi. So that will be the final answer will be the square root of pi and pi cancel, so the 150. The square root of 150 will be the 12 by 25. So this is for the RMS value 12 by 25. Okay, the next topic is the RMS value of the complex waveform. Then you can also calculate the form factor. The form factor equation is RMS divided by average. So now RMS is 12 by 25, average is 10. So form factor is 1 by 225. The form factor. So this is the equation that IRMS, VRMS, the V average. RMS is 12 by 25. Is 10, so this is 1 by 225. The form factor will be 1 by 225. Okay, so this problem, so waveforms are given. You have to calculate the average value, RMS value, and the form factor. So average value is that we use the equation. V average is equal to 1 by d, and 0 to d, integration 0 to d, vd dt. So this is the equation. So this is the equation. V average. So 1 by d, integration 0 to d, vd and dt. So this is the average values are calculation. And also RMS value. RMS value is square root of 1 by d, integration 0 to d, vd square dt. So this is the RMS value. The RMS is equal to square root 1 by d, integration 0 to d, vd square, and the dt. So this is two equations. Well, where to utilize these two equations and to calculate the average value and the RMS value. Okay, firstly we consider the first function. So this is a square waveform. Square waveform is between 0 to t, 0 to 10, then will be the 100, and 10 to 20, there will be 0. So we have to integrate for the one cycle. One cycle means that repetition. The same cycle will be repeated. This is the one cycle. So normally we use this one with this one. This is the one cycle. This is go here, this is 0, and this is from here 30 and go to the 0. So those functions are repeatedly coming. So this is the one cycle. And similarly, this waveform. This is the one cycle. So in this case, you have to integrate from 0 to 2t. One cycle. So this waveform will be also repeatedly. And from here, this one is a one cycle. This is also one cycle. So in this case, this waveform, you have to take t squared to 20. But here, t squared to 2t. But this waveform, t squared to 5. And this kind of waveform, t is equal to 20. So you have to integrate for the one complete cycle. After this, you don't need to worry about the rest. You have to integrate for the one cycle. For this waveform, from 0 to 10, there will be value 100, and the 10 to 20 value becomes 0. So the one cycle will be the 20. So t is equal to 20. But this waveform, one cycle will be the 0 to 2t. So those waveform will be repeatedly coming out. So this is one cycle with the t is equal to 2t. Here t is equal to 20. Here t is equal to 5. So those things we have to substitute. Okay, we start the substitute for the first thing. So the average. So 1 by t integration 0 to t vt tt. Okay, in this case, one cycle is at 20. So this is a 1 by 20. So integration 0 to 10. 0 to 10, Vt is the force function, 100. So this is 100 dt. 100 dt plus integration 10 to 20. So this is a 0 dt. So this we go like this. Okay, here the calculation, this one with 0, everything will be the substitute 0. This one becomes 0. Only this one left. So that you can substitute here. So this becomes 1 by 20. So integrate, so this is a t. So 0 to 100 and a 0 to 10. So we go like this. So you substitute the 10. So this becomes 1 by 20. And 10 into 10. So then here we got the thing. This becomes as 1000 by 20. So 1 by 20, so it becomes 50. Okay, every becomes 50. So this is 50 volt. The average is 50 volt. And also we can also calculate the VRMS. The formula is square root of 1 by t integration 0 to t vt square and a dt. So this is the generalized formula. So in this case, t is value that we can substitute. T is at 20. So 1 by 20. So you integrate from 0 to 10. Vt square means 100 square into dt plus integration 10 to 20. We integrate 0 square to dt. So we got, so that 0 square to dt means that this is as 0, so the whole thing becomes as 0. So only this one left. So this one becomes a square root of 1 by 20. Multiply, so this is a 100 square. So this is a t 0 to 10. So this becomes a square root of 1 by 20 multiply with, so this is a 100 square to 10,000. 10,000 multiply, so this is 10. So this is a square root of, so this becomes as 5,000. So 5,000 is 70 by 7 volts. So the RMS is 70 by 74. Then we can also calculate the form factor. So V average divided by V RMS. V RMS divided by V average. So the form factor. So the V RMS by V average. So V RMS is 70.7. V average is 50. So this is 1.4142. So form factor is 1.4142 for the first problem. Okay, so number B. So number B is that this is a sawtooth waveform. So sawtooth waveform, I already give you that formula to sawtooth waveform. ID is equal to I maximum by T multiplied by T. So this is the equation for the sawtooth waveform. ID is equal to I maximum by T multiplied with T. So this is the equation for the sawtooth waveform. So in this case, this equation, maximum voltage is the 5. The maximum voltage is 5, so the I maximum you can substitute the 5. And period T is at 20, so you have to substitute at 20 in the place of the period. So then we began the 5 divided by 20 into T. So then we got the 0.25 T. So ID is 0.25 T. So that's all. Then we can substitute every value. Every value we substitute in this formula. So the V average is equal to 1 by T integration 0 to T and the VDDD. So this is the VDDD. This is the for the voltage, that will be the V maximum by T. So that this is the VT into TT. Okay, then we substitute here V average. So period T is at 20. 1 by 20 integration 0 to 20. Integration 0 to 20 and the VD is 0.25 T. 0.25 T into TD. We got. So this one we now integrate. So 1 by 20 multiplying 0.25. So this is the integration. T integrate, so this is the T square divided by 2. So this is 0 to 20. Okay, you substitute at 20, so this becomes a 1 by 20 into 0.25. So this is a 20 square by 2. So 0, you substitute, it's a 0. So this becomes a 20, 20, so this is a 0.25 into 20 by 2. So this is a 2 by 5 volt. So every body is 2 by 5 volt. So this is for the average. And also IMS, you have to use the formula, the IMS. So the equation is the square root of 1 by D, so integration 0 to D, VD square dt. So this is the IMS value. So square root of 1 by D, integration 0 to D, VD square into dt. So those now substitute here. So square root of 1 by D. 1 by D is 1 by 20. Integration 0 to 20. VD is the 0.25 T. So 0.25 T, the whole square into dt. So we got like this. So this becomes a square root of 1 by 20. So 0.25 coming out to 0.0625. So this is T power 2 by 3. T power 2 by 3. So you have to substitute 0 to 20. So this becomes 1 by 20 multiply 0.0625. So T power 2 is at 20 power 2 by 3. Okay, this one becomes, so this becomes a square root of, so this is a 20 into 0.0625 by 3. So this is 0.0625 coming out to 0.25. So this is the 6.66. So 2 root of. 20 square. So this is 20 square here. So this 20 square, so 0.625. So 20 square is coming out. So this is a 0.25 multiply 20 divided by 1 by 2, 3. So this is 20. So 5 divided by 1 by 7321. So 5 divided by 1 by 7321 is, you got that are 2.8874. Then you can calculate the form factor. So the average value divided by IMS value divided by average value. So V IMS divided by V average. So IMS is 2.887. Average is 2.5. Then you can calculate the form factor. So form factor becomes 1.155.